Hi friends, welcome to ScienceX channel. In this video, we are going to make the self-balancing robot. Let's get started. In second part, we are going to make the calibration and testing of the robot. First, we have to do the calibration. For that, we have to place the robot in the leveled surface. Okay, look like this. And place the weight both sides, then only the robot will not fall down. Okay. So before placing the weight, you just move backward and forward and place the position exactly where the robot lies vertically. Okay, that is called the center of mass. We have to place the center of mass in the leveled surface first. After that, we have to fix the robot using weights like this, look like this. Okay, then we have to upload the calibration code. The code will be given in the description box. You download it. Okay, then open the code using IDE, Arduino IDE. Okay, just click the OK and then it will appear look like this. So this is the code for only calibration. Okay, first we have to verify the code. There will be no error in this code, so it will give 10 compilation, so there will be no error here. Okay, then we have to upload the code into the board. Okay, so now is uploading, done uploading. Okay, the code is uploaded now in the board. Now we have to open the tools and then serial monitor. Okay, so in serial monitor we have to fix the 115200 baud rate. So once you open the serial monitor, it's asking to press any key. Okay, we have to press the key and then the calibration will started. Okay, after checking the sensor and all, it will give the offset value of the robot. Whatever the position we are placing, we need offset value, gyro and accelerometer offset value. For that we need this calibration. So here once everything is over, the offset value will displayed on the serial monitor. So I highlighted here that values we need to enter the main source code to the Arduino board. Okay, so now we have to enter the full source code. For that we have to test the robot whether it is working good or not, because we added L298N driver and MPU6050 sensor. The both component whether it is working or not we have to check. Okay, that is the second part of the calibration. First calibration, we have to place the accelerometer and gyroscope readings. For that we did previous calibration. Now we are checking MPU6050 sensor and L298N driver calibration. For that we need to upload main source code from this source code file code. Okay, I given this code also into the description box. You just download it. So in this code we need 3 libraries we need to run this code. Okay, one is I2C dev library, another one is L motor control library, another one is PID library. Okay, so you have to install these 3 libraries before running this code. I am giving the explanation, complete explanation how to install this library in a separate video. Look at that video for installing the library. If you are not installing the library, the code will not work. Okay, it will show error message. We have to avoid that. After installing 3 libraries, we have to open this code and then we need to change some corrections. Okay, for that first we have to check the set point. You just scroll up and down and where the set point line will appear, and then KP, KI, KD values, and then motor driver pin configuration. So 3 things we have to note. Another one is we have to see the gyroscopic and accelerometer readings. So previous calibration we will take the offset values. Okay, we have to enter here. So this value we have to enter in this code. Just scroll down, you get this line. Okay, so we have to change the value according to our position, sensor position, as per the calibration value. You just enter these values one by one very carefully. So we need 4 values only. So totally 6 values the calibration give. We need only 4 values for this code. Okay, gyroscope X, Y, Z axis and then accelerometer Z axis values only we need. So you have to carefully enter these values. After entering this value, we have to do one more checking. okay, whether the L298N driver and MPU6050 working or not. You have to check for that. Okay, so after uploading, you paste two tapes for both wheels, look like this. Okay, then you place the robot in a elevated position like this. Okay, after uploading the main code, we have to do this procedure. Then you just switch on the robot whether the L298 is working or not. Okay, if that is working, both wheels should rotate in the same direction. Okay. See this checking, it is working very nicely. Both wheels are rotating same direction. Then you have to take the robot somewhat highly elevated portion. Then you have to tilt backward and forward direction. So while moving the backward, both wheels should rotate in a backward direction. While moving forward to the robot, the wheel should be rotated in the forward direction. So according to the tilting of the robot, the wheel should be rotated. Okay, if you are making center portion, the wheel should be stopped. So whether it is working or not, we have to check. This is also another important portion. Next, we have to change the KP, KA and KD values present in the source code for making the stabilization of the robot. Okay, while moving the robot, it should not fall down. For that, we have to make the PID tuning. For that, we have to change the KP, KA, KD values present in the code. So after changing the code with the different values, KP and KA values, and you check whether it is robot wheel should not fall down, also it should not oscillate fast. See here, I given KP value 30, KA value 0. Okay, you see that robot is falling down. Okay, it means that we have to increase KP value somewhat higher value. We have to give the KP value. Likewise, we have to change the KP and KE value, KI, KD. Three values we have to change. Okay, according to the requirement of the robot. Robot should not fall, should stable in a vertical position. For that, we need this PID tuning. Without PID tuning, we can't use this robot as self-balancing. So PID tuning is very important. You just make sure we have to make the values up to the robot will stabilized without vibrating, without falling. Okay, we have to make this change. So this is all about the calibration. Next, we have to go for testing. Come, we'll see the output of the robot. Friend, this robot is working very nicely. It is noted that for self-balancing robot, center of mass and PID tuning and calibration, the three parts is very important. This is all about self-balancing robot. Friends, if you are not subscribing my channel, please subscribe. Subscription is very important. It gives more energy to produce more and more videos. Thank you for watching, friends. We will see in next video. Bye.